So welcome back to Semicon West here at Phoenix, Arizona. Delighted to be joined by Professor Alan Montooth. Thank you for coming in, Alan. And you head up the UP, is it UP Power Group?
UA Power Group.
UA Power Group,
yes.
At the university. It's quite a sizable concern. So for those of our viewers that are not familiar with it, can you give us an outline of the group?
Sure. So the UA Power Group is a power electronics research group at the University of Arkansas that has grown from 4 faculty to 25 faculty over the last 20 years. So very measured growth. It's about 200 graduate students. So in the program, and it's definitely the largest in America now.
Right.
Very vertically integrated program from materials to systems. So we do work at the semiconductor level, but we also do materials for packaging. And so again, with this work, we then build on that foundation, do electronic packaging, modeling and simulation, circuit design, both IC design and power electronics.
Okay.
Integrate all this together into advanced integration for things like power modules, power converters that would be in electric vehicles, the grid modernization.
Right.
And so with those, you go all the way to the system level. And so we have experts at all those levels with those 25 faculty. And it's very collaborative across like 6 different departments.
Right.
So it's very interdisciplinary: chemical engineering, mechanical, electrical, material science, and physics, and chemistry. So all of these are players in this.
It's incredible how you put an end-to-end system together, which really takes products through from prototyping right through to first article and help introduction into scaling them up for production.
That's right.
Now, one thing that's at the heart of all this is your work on silicon carbide, though, which has been used a lot, of course, in the power modules industry and this type of thing. Can you elaborate a bit on the work you're doing with silicon carbide?
Yes. So we've been involved in silicon carbide for the entire 26 years that I've been there.
Right.
I actually started the work in silicon carbide and wide bandgap through some collaborative work when I first came back to the university from industry. And so first it was modeling and simulation, then it was packaging, then it was power converter design, and it started growing from there. Then we started getting more industrial in relations, starting in, say, 2005, 2006. And it really took off from there. And so our decision to build a silicon carbide fab, the music facility, Multi User Silicon Carbide, the reason for that was that we were finding no place to prototype our ideas in integrated circuits or power devices. And frankly, everyone in the nation was having the same problem. And so about 2017, we decided, now's the time. We need a place to do this. And it takes this long to really make that come to fruition.
Right.
We had the vision, we got the funding, we've built the facility. It now opens in November of 25. And that's really our journey in silicon carbide. In a lot of ways.
That's really exciting. I mean, it's quite a journey too. But I mean, you call it, the acronym is music because it's multi-user. So what is the multi-user facet of it?
Good question. So multi-user refers to the fact that this is an open facility. Not that people come in and use our equipment per se, but they'll come in and they'll work with our design intake team.
Right.
And if they want to build something and prototype something, then we will build it for them. We have a staff of engineers that will run the facility. So the facility is not run by students and postdocs. It's run by full-time staff.
Really?
Now, of course, workforce development is a big part of this fab. And so we will bring students in for training, and they will have the opportunity to use the equipment. But at the same time, when we're talking about prototyping, we have to have very good process control and repeatability.
Right.
And because if I run a prototype for you, and then you say, ooh, I want to make a change. That was really good, but I need a little tweak. You need to be able to count on repeatability for that to have value and ramp to production ultimately.
Right.
We're not the production house. We will transfer the work over to a high-volume manufacturer, like XFAB Texas, for example, a pure play foundry, and then they would be able to have a client that needed high volumes.
Okay. What about IP in some of these situations? I mean, companies are very sensitive about that.
So we've spent no small nickel on cyber physical infrastructure to protect company IP. I'll give you an example. If a company is running a process recipe in one of our bays, If you do not have permission for that process, you can't even badge into the bay.
Really?
Okay, so the recipe, the cyber physical security is all tied together. Once that process has run to completion, the data and the process recipe is downloaded to our secure servers and replaced with open source process recipe,
Right.
thus opening the door for other people to be able to enter.
I see.
So in that way, it's all automated. The handling of the IP and the compartmentalization of that work.
You also give it different names, don't you? You don't give it the actual name of the customer. You give them.
That's right.
rather
We'll even
novel
code
names.
name the customers.
Right.
But on top of all this, remember, faculty, students, and postdocs will not have access at all.
Yeah.
Just the staff, and then under a code name. So the staff will be the front line working with clients to do that IP protected work.
And the staff have come from industry.
They are. We're hiring staff back from industry. We're doing it two ways. We're hiring senior process engineers back from industry. We're hiring some of our own graduates to be junior process engineers to learn at their feet.
Right.
So we can train up a workforce. They may work for us for 5 years and go to work for Texas Instruments, and that's a great model because they go out into the industry as well.
Yeah, of course.
So we'll be bringing in young talent to work under the tutelage of these more elder statesmen.
Right. So, after having done all the work on the prototyping, etc., there is also a packaging element to it.
Yes.
I believe you've started another area
Right.
that handles just that.
Well, we did. So, in fact, Arkansas has a very long history of electronic packaging dating back to 1991 when DARPA funded us to do thin film diamond and multi-chip modules for high-speed digital.
Right.
We did that work for 10 years under DARPA funding. About 2001, 2002, we began to pivot to power electronics. And this is when the power group was kind of formed. And we started doing power module packaging. And so for the last 20 plus years, we've done power module packaging, and it necessarily took on the wide bandgap silicon carbide stuff because that was emerging. And so as a result, we've had a long history there. Now, with the fab coming online, we're going to do both continued power module packaging work as a back end to our power device fabrication. But the silicon carbide CMOS, which is LSI to VLSI, that we'll be doing for harsh environment electronics, we'll also be doing packaging of those as well in a quad flat pack or whatever it might be, ceramic packages for harsh environments.
Correct.
So we'll have that capability as well.
Super. Well, it sounds like you've got a very comprehensive setup there, Alan, and I want to congratulate. Obviously, it's your energy that's brought all this together. So congratulations on that, and thank you very much for coming in and telling us about it today.
All right, thank you. You're welcome.
For micro dispensing, there is one product line that is proven and trusted by manufacturers in semiconductor packaging, electronics assembly, medical device, and electromechanical assembly the world over. DL Technology, superior pumps and needles for the finer things in life.